Today we, Group 11, will introduce our research project on the coagulation-flocculation process to maintain public health, the sanitation and treatment of raw or untreated wastewater into our daily drinking water. First, we will talk about the coagulation-flocculation process. So what is coagulation-flocculation? It is a chemical-physical process in which chemical coagulants are used to manipulate the electrostatic charges of colloidal particles, causing their cohesion, agglomeration, and eventually sedimentation. Cool coagulation concept! Coagulation and flocculation can remove up to 99.9% of bacteria and 99% of viruses from water supplies. Here is a picture which shows what happens during the process. A coagulant of opposite charge to the particles is added into the solution to neutralize the charges of colloid particles, decreasing the electrostatic repulsion, which leads to the formation of microflocks from the aggregation that destabilizes particles. The flocculation stage is the agglomeration of these microstructures in flocks for enhanced removal that includes gentle mixing to encourage the collision of microflocks together and steadily build up size. Once flock sizes reach the desired size and strength, these colloidal structures are removed using sedimentation. Flocculation fun fact! Coagulation and flocculation turn nasty submicroscopic particles into visible suspended particles that are easily removed. Next, we will describe the coagulant that we decide to use in water treatment, which is polytitanium tetrachloride, also called PTC, and the reason it is chosen amongst the other types of coagulants. Recently, polymetric metacoagulants are increasingly being used to improve coagulation efficiency. PTC is a novel polymetric metacoagulant that has shown great promise to make our drinking water safe. To overcome the sludge disposal problem, a novel titanium coagulant was proposed, and for water purification. The most significant advantage of titanium-based coagulants is that the final coagulated sludge can be recovered to produce valuable titanium dioxide as a byproduct, which can be used in many industrial applications, including photocatalysts and cosmetics. Because of its biocompatibility, titanium is used in a gamut of medical applications, including surgical implements and implants. PTC is synthesized from titanium tetrachloride via a method called slow alkaline titration. Using sodium hydroxide and vigorous agitation, PTC is synthesized from a 20% titanium tetrachloride aqueous solution. In comparison to PAC, under optimum conditions, flock growth rate and flock size of PTC is higher than PAC. Also, it gives more compact flock structure, therefore it requires shorter retention time. Moreover, the sludge from PTC flocculants was able to recycle and produce a functional titanium dioxide photocatalyst. On the other hand, using PAC as a coagulant has low generation of waste sludge and is versatile, so can be used in a wide range of applications. In comparison with titanium tetrachloride, higher turbidity and organic matter removal efficiency could be achieved by PTC with improved flock characteristics like size, growth rate, and structure. With higher flock growth rate and larger size, this can minimize the size of the mixing or sedimentation tank, thus results in more financial benefits. Furthermore, PTC flocculants contribute into improving water pH toward neutral. Terrific treatment truth! Less than 1% of the water treated by public water systems is used for drinking and cooking. Apart from various advantages from using PTC as coagulants, there are still some limitations. First, PTC flocks require careful handling during the separation process due to its low recovery factor. Next, PTC coagulants need to be processed in strict ranges between 5 and 9 pH. Also, the process is operated under low shear rate conditions. And lastly, PTC coagulant is only in early research stages. Even though there are some drawbacks, using PTC as a coagulant is still better than conventional coagulants and is worth trying out. We believe PTC is your future coagulant. We hope that with this research, we could provide more safe drinking water to the global population and also develop in order to improve the quality of the process. Wicked water wisdom. You can live for a month without food, but you would be dead after a week without water. We would like to thank Yuan Hao for his guidance over this semester. And finally, a big thank you to everyone for supporting us.
Free created using Powtoon.